Thank you.
All right. Now, HMPE fibres are what I often refer to as the last sort of quantum leap in yarn technology available to us as rope manufacturers. You may be familiar with Terylene back in the day, then Kevlar, and things like Vectran as well. Kevlar was fantastic, but it tended not to tell you before it was going to blow up. Vectran was incredibly low. We still do make some Vectran lines, but it's incredibly low stretch. But it has a tendency not to like going around corners, not to like UV all that much, and tended to also blow up without warning. So HMPE is this latest quantum leap in fiber technology. It's UV stable, really easy to splice, likes going around corners, easy to color, etc., etc. So these fibers I'm talking about now are the dominant technical fiber in the leisure marine industry. As I said, they're lightweight, high strength, they float and have very low elongation, which makes them kind of perfect for us sailors. Now, Marlow Ropes, amongst other reputable rope brands, tend to solely use Dyneema for their HMP supply. Dyneema is one of the most cut-resistant materials in the world as well. So we're using it in all sorts of industries across the spectrum for different reasons. For example, in the middle photo here at the bottom, you'll see that the D12 core is covered with a 48 plat tubular Dyneema product. This isn't designed for strength or stretch. That is just a protective chafe sleeve, what we call chafe cover, for the same yarn material underneath doing a completely different job. So the yarn material underneath is taking the load. That jacket on the top, it'll never be handled by a human or gripped or clutched because Dyneema is slippery, but it's the most cut resistant, chafe resistant material in the world. Okay, so we're using this fiber all over the place. Now,
no, I haven't.
sorry, with Dyneema being slippery, obviously we splice it most of the time. It makes it incredibly easy to work, but it does also make it quite adept at lashing, being lashed, because once you've hitched it into position, with it being slippery, it beds in and quite easily spreads the load between all the laps. So that photograph on the left is actually the forestay of one of the clipper boats. So they've done multiple laps to allow for the reduction in strength due to tying a knot in the rope. I'll go into this in further detail later. But because it beds in really nicely, that load is nicely shared out. Now, interestingly, these lashings for the forestay are changed at the halfway point of each race, and they're taken back to the factory for testing. And we actually found that they were 20% stronger than when they were brand new. And that's because of the pre-stretching process that we put our cores through has continued over that time, and all the fibers are really nicely aligned, and that sort of pre-stretching process has continued, and they've really bedded in now. So that was quite interesting. The biggest disadvantage or advantage of HMPE fibers is that it does have a relatively low melting point compared to a lot of other yarns. So if, for example, a sheet or a mooring line was to be whipped around a piece of Dyneema at a high speed, you might see damage quite readily, despite how abrasion resistant the fiber in theory is. As soon as you're bringing heat into the equation, Dyneema is not very adept. Now, thus far, we don't tend to recommend using Dyneema in standing rigging for monohull yachts, largely due to the fact that most of these boats tend to have a spreader or a bottle screw that doesn't interact well with the textile. A stainless steel wire will take the beating quite well. However, we have used it extensively for catamarans, trimarans, and occasionally with dinghy rigging. Now, that said, there are a handful of riggers out there pushing the boundaries with standing rigging, even in cruising yachts. So we, as a rope manufacturer, Marlow Ropes provide all their Dyneema cores, what we call D12, pre-stretched as standard. Okay, that's because we think that if you're buying a Dyneema rope, you want it to be low stretch. Therefore, why wouldn't we pre-stretch it? Otherwise, we're just selling you what is quite an expensive yarn, simply braided together. We also sell a super pre-stretched version of that product called D12 Max. And that's what we kind of recommend for use in high load static applications. So there are riggers in the UK playing around with and working with companies such as Hammer or Staylock or Blue Wave to try and come up with hardware that allows people to use Dyneema as their standing rigging option. As a rope manufacturer, we're playing it fairly safe for now. Stainless steel wire is fundamentally going to take bashes better. Yeah, as I said, the main issue they're trying to overcome was with hardware compatibility, mainly with spreader tips. No matter how much rig tension you're running, there is fundamentally movement at the spreader. Stainless steel wire simply withstands harsh edges and constant rubbing far better than any textile rope, solution. Equally, if you were to get a fender line or a sheet or a spring line when you're mooring up, rubbing over, then stainless steel, despite Dyneema's fantastic abrasion resistance, stainless steel will win that battle. Naturally as well, with a braided textile solution, you will see some movement after you've rigged the product. So where you splice a rope in particular, you're going to see some bedding in. So there's a whole different method of rigging the boat here with regards to rig, commission, take up the slack, and then there needs to be a program thereafter of doing the same thing as the product moves around. No matter how good us rope manufacturers claim our product is at being low stretch, ultimately, if you're using a stainless steel wire or rod and you're swaging or crimping it in whichever way you do, it's not moving much thereafter. With this being a presentation to marine surveyors, the best thing that I can extract out of what we call our rope show, which is an end user facing presentation we do in yacht clubs every now and again, is with regards to damage, fiber damage, and things to look out for, things to advise upon. As we're talking about Dyneema, I thought I'd start off with some basic things to look out for with them. Now that first photograph on the left actually shows the rope. We should have a photograph of the rope when it was still as it was on the boat, because from the outside the rope doesn't look too bad. You'll see on the outside fibers there are some small bits of damage. It's gone a bit hairy, but so it doesn't look too bad. But as soon as we bunch the rope up, you'll see that there you can see what we call internal abrasion. So our PU coating, which is in this instance the grey colour you see, tries to counter the internal abrasion by providing a protective layer between the braids. However, bend fatigue is still a feature. Now, the reason we've got a blooming great Mod 70 in the background here is because that rope on the left came off concise. That one in particular we were seeing challenges with bend fatigue because they were using D12 on very highly loaded, frequently moved applications. In this instance, is one of the hydraulic control lines for some. So I think it was the rig that was canting. So the sheave was quite gentle and nice. There was no damage there. The outside of the line looked absolutely fine, but when you bunched it up, you saw that actually that internal abrasion where the rope had been constantly worked under load was showing signs of wear. Okay, and at that point it needed replacing. Internal abrasion is also something that we see where contaminants have gone into the rope, particularly on yachts, more so than dinghies, because generally speaking, a dinghy will get hosed off with fresh water every time it comes off the sea. Yachts do get more contaminants into their rope more readily. And fundamentally, any contaminant that the rope isn't designed to have within it will act as an abrasive. Again, not always visible on the outside, but quite visible on the inside. The middle photograph is arguably the most simple situation. Simply that line has been sliced. So something sharp has plucked that braid out of the rope and cut it. You'll notice that where it has splayed out right in close to the rope is looking a bit fluffy, but that protruding yarn is very clean cut at 90 degrees. That indicates a sharp object. Okay. And as I'll go into later on in the presentation with another example, this isn't necessarily a rope issue. It's the nice thing about rope is that it quite often gives you, it's your first sort of clue as to whether there's a hardware issue or something left on the deck that shouldn't be left on the deck. The last one, the bottom right hand photo on this slide, isn't really damage. This is what we call cold molding. So I think this the rope in this photo is the same as the one on the left hand side. It's something unique to Dyneema, and it isn't actually anything to be concerned about, that glossy finish on the outside of the bend there. When a Dyneema line sits under something under load for an extended period of time but doesn't move, i.e. the dead end around a pin, for example, it will settle into shape. So that's what we call cold molding. It hasn't gone through any grief and it's nothing to worry about. You'll notice that when this happens, the line's been under enough load for it to have memory. So it will stay in that eye shape when you take it off. I wouldn't recommend squishing it or moving it or undoing any of that. I'd leave it as it is because that's nicely bedded in to the shape that it wants to be. I've added this slide in since I last did this presentation, and it's actually plagiarized completely from a presentation that we had from Avient, which is the company that supplies us our Dyneema yarn. Okay, because for yacht surveyors, something to be wary of, not necessarily beating the drum off, but just something to be wary of is with the quality of ropes. Now we are a premium brand at Marlow Ropes, and there are other premium brands around. Most of them will only use Dyneema as their as their supplier of HMPE. A good example, HMPE was largely pioneered by Dyneema. And a little bit of history, Marlow Ropes actually went into administration in the mid-noughties because we were supplying very high quality yarn solutions for oil rig towing. Now, in a short period of time, companies from all over the world worked out how to get hold of or manufacture quickly an HMPE fiber and therefore they could produce reasonable quality, high diameter lines at a fraction of the price to what we were producing. And because a lot of these lines are single use, it all came down to price. And so actually we had to exit that market within 6 months. And so we in our company we refer to old Marlow and new Marlow, because we've had to do away with that side of the work, that side of the business. So what the upshot of that is that that kind of has trickled down now into the yachting world, where it's fairly straightforward to get hold of what we refer to as generic HMPE fibers, and they look exactly the same to the eye as Dyneema, but they are lower quality. They're fundamentally gel spun, and it's at a molecular level what's going on, but fundamentally the fibers are more aligned in Dyneema and their production processes are more consistent. So we only use Dyneema in our leisure marine world, in our leisure marine market, but you need to be aware of brands that are selling an HMPE. So HMPE is the type of yarn material we are using. Dyneema is a supplier of an HMPE fiber. See that the availability of generic HMPE yarns from around the world at very reasonable prices has enabled many rope brands to be able to offer a lightweight performance rope at a very reasonable price point. Now, bear in mind, Dyneema is a bit of a buzzword. It's the colloquial word we use for any rope that's got HMPE. So you need to be aware that the customer may have been sold something under the guise of it being Dyneema, but it may not be. So yeah, this slide isn't my own, but it kind of shows you how much research the Avient have put into this topic, because obviously it's a bit of a threat to their business. But you're seeing far better performance, overall performance from Dyneema supplied HMPE, so SK78 or SK99 yarns, than what else might be available at a very attractive price. On to cover damage, things to look out for. This example shows what looks like fairly ordinary rope wear, but it's a bit premature. You'll see the rest of that green rope is actually pretty much as good as new. So this rope has worn prematurely. And so the thing to look out for really here, and obviously the damage is localized. Okay, it's only across a foot or half a foot of the rope. And this is generally caused by slippage within the clutch, and where the teeth have worn down and sharpened. Okay, so to stop clutch slip, you must service the clutch. You don't need to buy a new clutch. If it's a spin lock one, you can just replace the inserts. And at the same time, you shouldn't just be replacing the rope. If it's worn out before the rest of the rope has aged appropriately, then you ought to be looking at the hardware it's interacting with fundamentally. On this point, a rope is not designed to look like it does in the chandlery or the rigger forever. Actually, quite often when you buy a rope brand new, it is performing as badly as it ever will. Our ropes are designed to fluff up a little bit fairly quickly, and at that point, all the materials and the careful design of the jacket is that they're actually working together to improve the performance. Therefore, if you simply replace a rope that has worn out without checking the hardware, you're likely to see the problem worse with regards to slippage straight away. Generally, a clutch's teeth will wear out to the old rope and then you put a new rope in it and the problem's even worse, as well as the new rope being slippery anyway. Okay. In this particular instance, you see on this slide, the teeth have worn away because, and with the heat of the rope whipping through, that has damaged the teeth and worn away the anodizing that you see, the aluminium anodizing that you see there. Now, as soon as that an anodized aluminium surface is worn away, you've got the bare aluminium underneath, and that effectively becomes sandpaper. Okay. Now, what a lot of yacht owners might be inclined to do at this point is to upgrade the rope. So in this instance, that's a polyester jacket. They may wish to upgrade the rope to something with Technora in the jacket, and that is only going to make the problem worse, even if you replace the cams like for like. Okay, Spinlock offer aluminium cams and they offer ceramic cams. As soon as you're using any sort of aramid fiber such as Technora, or what a lot of manufacturers refer to as Cordura, two different yarns but quite similar properties, you need to think about upgrading those cams in the cleat as well. Okay. Similarly, on smaller boats, the same problem exists with ratchet blocks. So a lot of mid-range ratchet blocks, they move from the very smallest dinghies up when you're moving into small keel boats and small yachts. You'll have a ratchet block with an aluminium sheave. Okay. Now, with us rope manufacturers coming up with all sorts of fancy ropes for people to replace, they do start to use their old hardware with modern fibers. Over time anyway, a ratchet block's anodizing will start to wear away, but in recent years this has started to increase with us introducing, very helpfully, fibers like Technora into smaller boat sheets for its various advantageous properties. But what that means is that old ratchet block, which may have been fine for 20 years, with a polyester rope running through it, very quickly, suddenly, actually, the anodizing is wearing away. Now, that can result in a very disappointed customer because they've spent money, more money quite often, on an upgrade to their sheet, but it's worn out immediately. The same problem as seen on a 40-foot yacht can happen on a dinghy or a small keel boat because that naked aluminium becomes sandpaper, and no matter how fancy the rope is, it's not going to last as long as you'd hope. So another thing to be aware of. Just look inside the sheave, the teeth of the sheave. You see those little hexagonal or square silver marks on each facet. Probably need to replace the ratchet block. This kind of failure is what I referred to earlier when we were looking at those clean cuts on the Dyneema core earlier. This type of failure has been caused by something sharp on the deck. You'll see very helpfully the lines that demonstrate the damage are at 90 degrees to each of the splayed yarns, but it kind of shows how clean the cuts are. You'll see that there isn't much furring, that there isn't much fur involved in the damage. The splayed yarns have been cut clean, and that's a pretty clear sign that it's been picked and cut by something sharp. I think in this instance, there was a shard on the shroud the sheet was catching on and tearing on. So although the sailor, as again, you'll see that's not a very old looking rope. A very disappointed sailor had to replace the sheet. It was a good thing because it highlighted that a rig inspection was required and they needed new shrouds as well. Twist. Twist is something to make your customers aware of. Twist creates unwanted friction, failures, because once a rope is twisted, only a small portion of a contorted rope will be taking the load, which reduces its capability and obviously potentially creates loops and knots. The number one cause of twist is the hardware and hardware alignment. So in this picture here, the big picture, you'll see that Another block forward of the mast has been tied to the bottom of this block with the yellow line going through, and that is just contorting its angle away from the true lead of the rope. The red line is absolutely fine because that block is unaffected and is as it should be. The other thing to be aware of are winches. Not that we can help it, but just make the customer aware that, oh, your sheet looks very twisted up. You're obviously sailing with winches, so periodically it's worth throwing the rope overboard out the back and untwisting it, or manually doing so with a short length of D12 Dyneema, which is slippery. You put a lark's head around and just milk the rope back down. Ultimately, there's only so much you can do, because generally with a covered rope, twist isn't simply the whole rope twisting. You've lost the relationship between the core and the cover. The jacket's moving separately to the core, but you can help. Other ways of avoiding twist is by choosing blocks that are 10% bigger than the diameter of the rope. I used to work at Harken. I worked at Harken for 6 years. Our catalogue had recommended line sizes for each block or each winch. We try and stay 2 mil below that max line size that's advertised by hardware manufacturers. A 57 mil block may take a 10 mil line, but generally we're aiming for 8 mil to go through that for maximum efficiency and to ever avoid the rope just touching the sides and becoming inefficient. What you're also doing as an aside to that, what you're also doing by reducing that line size according to the sheave size is making sure that the loading is well within what the block is capable of doing. Okay, so the smaller the line, you're generally working with a lower load, that block's going to be less friction anyway, so it's an upgrade in a way. Obviously, making sure a rope runs directly through a block, not at an angle, is a pretty key way of avoiding nurturing a twist into a section of rope. And also, if a line is tapered, not that we see this done very often on cruising yachts, if a line is stripped and tapered, make sure that that tapered section, the bit where the job is done, isn't running through a block repeatedly. If that's the case, that will also nurture a twist into one side, one section of the rope. Equally, simply coiling a rope the way we want to will also create induced twist. We have a video online as to the correct way of coiling a rope. Generally speaking, us yachties are pretty poor with our rope discipline compared to arborists, rock climbers, etc. There's a lot to learn from them. This is a fairly easy one. I'm sure we can all work out that rope has melted. We are seeing this mostly on boats that have been bought second-hand from an owner that used to do a lot of cruising, and it's now been bought by someone quite keen, who's keen to do a bit of club racing or whatever, and they haven't changed anything on the boat, or they've upgraded the hardware and the sail plan, and they're ripping through maneuvers a lot harder, and you're generating heat around the winch drum and melting what has been a perfectly good rope for many, many years. At that point, they may want to consider upgrading the line accordingly. And at this point, we might have a conversation with them about maybe introducing a rope with a bit of Technora in the jacket. Technora is very heat resistant, very abrasion resistant, it's grippy when it's wet. So it's kind of ideal for that kind of application, but it's more expensive. Now, as I said earlier, standard polyester ropes are load bearing in the core and the cover. So as soon as you're seeing core damage on any polyester ropes, that rope needs replacing. A Dyneema rope can take a lot more beating on the jacket before it eventually gives way. Okay. Now, this red rope on the left, that particular type of damage has been caused by a split ring, gently grabbing and pulling the cover and just gently plucking away each yarn. It's not a fantastically cut photo because it makes the cuts look 90 degrees, as I described earlier, but actually that's actually quite fluffy. Okay. And on the right hand side, that shows how if the core eventually was to be pulled out, there's a tiny little section of the blue rope, the blue jacket, taking the entire load of the rope. Knotting rope is fine. It's quick, it's easy, but customers ought to be aware of the loss of strength when tying knots instead of splicing. I can't speak for other brands necessarily, but Marlow Ropes advertise all their loads based on an average brake load. The highest and the lowest aren't much good to us. An average brake load, and that stated load is also a spliced load for the rope. Okay, so as soon as you're tying a knot, such as a bowline, even in double braid polyester, you're losing up to half the strength of the line. Equally, knots can come undone. Splices are much less likely to do so. If you apply the same concern to a Dyneema rope, a 12-strand Dyneema rope, you're seeing an enormous loss in strength. Similarly, Dyneema is more slippery than polyester. So do you really want to be tying a knot at all? Bearing in mind that a lot of lines on a yacht work at a 5-to-1 safety factor, it's a bit scary. I'll just go into the reason, actually. The reason why knotting a polyester versus a Dyneema rope affects the strength so badly. In a bowline, for example, you'll see at the top of the knot, the rope goes around quite a sharp bend. What that means is that the inside fibers of that bend aren't doing much. The outside fibers are taking all the load. Okay. So on a double braid polyester, the rope isn't pitched is pitched quite accommodatingly. So it does spread the load out better than a 12-strand Dyneema, where the fibers are quite well aligned for a straight load. As soon as you're bending that, those inside lines are doing even less, and there are fewer outside lines taking the load. Okay. Generally, we try and keep a rope bent as little as possible. Okay. In testing on sheaves or as loops, less than a 5-to-1 D to D ratio results in failure on the bend and not in the splice. Splice, if everything is correctly, if the loop is a wide enough bend, a rope should fail at the splice. But as soon as you're below that 5-to-1, things tend to break at the bend. Less than 3-to-1 guarantees a failure in the bend. And obviously most knots have a D to D of 1-to-1 or less. There we go. The next slide is a bit of an eyesight test, but is particularly useful. And we can share this image. I think this image is available on our website, but we do have hard copies of it if you'd like one to refer to every now and again. I think that brings to a close my section of the talk. I hope that was useful and informative. If anyone has any questions, please go ahead.
Thank you, Rob. Any questions in the room?
Yeah, I've got one moment.
Look, just bring this down. Hang on.
Hi.
Hello.
I was just wondering, when you're talking about the contaminants coming into the inner braids, is it worth taking Dyneema ropes off and washing them like periodically or annually or something like that? Or is the damage done by then?
Yes, is the answer. This is a common question, actually. First thing to say is please don't put ropes in a washing machine. This is the long answer, so buckle up. To make rope, you take flat yarn, just like with our clothes, and you twist it in the Z and the S direction. You then twist those two together to create your strands that you then braid the rope and do all sorts of clever things to it afterwards with. Those twist settings and thereafter the tension at which we braid and pre-stretch, etc., the rope are what really drive all of our expertise as rope manufacturers into what you get at the end of the day, be that strength, handling, abrasion resistance, etc. As soon as you throw a rope into a washing machine, you're basically jumbling all that work up. So the rope might look fantastic and feel fantastic, like your clothes do, having been in a washing machine. It's actually a fraction of the product you bought in the first place. The best thing to do is to just take the rope off, dunk it in a bucket of fresh water or water with a bit of detergent in, rinse it off in the morning, and that's the best you can do a lot of the time. I've been guilty of this in the past as well. The temptation with mooring lines in particular is, because they go green, is to pressure wash them. Now that does make them look fantastic, just like washing them in a washing machine. But actually using a jet washer only fires all those contaminants further into the rope. So it makes the outside look fantastic, but actually you're doing more damage. Partly through just pressure washing a rope will damage the fibers, but also you're just firing those contaminants further into it. With regards to regularity, it kind of depends on where the boat is, what type of sailing, and how they're feeling, basically. A difficult question to answer.
Any other questions?
Yeah. For me, as regards to Dyneema rope, do you supply any for anchoring practicalities? Just that in the offshore industry, D&D have got very specific guidelines for non-wet storage of Dyneema rope.
Couldn't quite hear that question properly. Something to do with using Dyneema for mooring ropes?
No, for anchoring purposes.
Anchoring purposes, okay.
Do you sell them for anchoring purposes, or is that a kind of no-no for that?
It's not necessarily a no-no. Anchoring vessels, we generally don't use Dyneema because it doesn't stretch. It'd be perfectly strong enough, but it's going to jolt, so it'll either pull the anchor up or damage the windlass or chain stopper at the top, whatever you're using, the hardware. Similarly, that's why we don't tend to use Dyneema for mooring. Super yachts are starting to use it because it's so light, so easy to handle, but we have to introduce a stretcher section to allow for panting, allow the boat to move, basically. Otherwise, you're going to be A, uncomfortable, B, damage the hardware. So that said, we do supply a lot of deep sea mooring, so weather stations and things like that, buoys basically, which are moored up with huge great long lengths of Dyneema, a mixture of Dyneema which floats and a rope that doesn't float, to create an S bend in the line generally halfway along the length, so that the rope isn't dragging on the seabed, but there's an element of suspension and allowance for waves, etc., to secure the buoy. Is that helpful? I've lost sound.
That better? Can you hear me now? No.
Yeah, I can hear you now.
You can.
I can see
Okay,
you as
sorry.
well now.
I found that really interesting, Rob. I'm, not a technical guy, everybody knows, but just goes to show you've got to keep your eyes open for these things, doesn't it? And who knows what you might see.
That's
Okay,
right.
fantastic.
And I'm on the end of the phone if ever you have specific questions. The best thing that surveyors can do, actually, I'm sure you're aware, is to build a relationship with a qualified rigger nearby, like the guys that are going to come in soon. They can comment. They've got far more experience even than me at looking at things and thinking, ugh. Have the guys from crew arrived?
Oh, yes, they've been here all the time.
Well done.
Are you staying online, Rob?
I can do, yeah.
Oh, it's up to you. I mean, I'm not going to force you, but if you want to hear the
No,
guys speak.
I like to hear what they've got to say.
Okay, fantastic. So let's have a round of applause for Rob, please. Thank you very much, Rob.